Okay, when multiplying polynomials, we have with grouped factors, we want to expand or distribute term by term. So a grouped factor, again, is the factor that has more than one term in it, and we'll see that here. So some of the things I'm going to be talking about, some of the terminology is factored form and expanded form. So if an expression is in factored form and it's just one term, there's no plus or minus outside of grouping symbols. If it's in expanded form, then the expression contains more than one term. So I'm just going to be talking about and using those terms um, when I go through this. So the first one, multiplying a, we notice this is actually one term. So there is no plus or minus outside of parentheses. So here's a grouped factor. So this grouped factor has two terms. All right, so in order to multiply, we take the 22x, which is just a term, and distribute it to the two terms that are in here. So each one of those is going to get distributed to. So when I multiply the 22x to each term, so the first one, I'm going to take the 22x and multiply it by the 10x to the fifth. So that's going to produce a term. So we'll go ahead and multiply 22 times 10, which is 220. And then x times x to the fifth, just using our counters, this would be x to the sixth power. So I also need to distribute the 22x to the second term, which is x to the fourth. So that's what the distribution looks like. The term value here now would be a positive 22 x to the fifth. So once I'm done distributing, I have two separate terms. I cannot combine the terms, these two separate terms, because they're different. They're not like terms. They don't have the same variables to the same power. So this would just be my answer. But we started with one term, basically factored form. And when we distribute term by term, we end up with two terms, which is expanded form. So it allows us to write expressions in factored form to expanded form. All right, the next expression, if we look at this, again, the parentheses are grouping our three terms inside. The three terms are 4c cubed, and a negative 9c, and then a negative 8. So the 5c squared is a term that needs to be multiplied to each one of the terms here. So I'm going to create three separate terms, right? So the first one is 5c squared times 4c cubed. So I'll just write that. And when I multiply this together, 5 times 4 is 20. And c squared and c cubed would be c to the fifth. It's just 5 factors of c. The next term, if you notice, the factors are negative 9c times 5c squared. So if I just multiply 5 times negative 9, I'm going to get a negative 45. And then c squared times c, that would be a total of 3 c's. So the last term then would be a 5c squared times negative 8. So negative 8 times 5 is negative 40. And then I have c squared as my other factor. So again, I'm just distributing term by term, using what I know about distributing monomials, using factor counters, basically the exponents as factor counters, multiplying the coefficients or the constants. So again, these terms are not alike, so I have to leave the expression in expanded form. Okay, what if I have multiplying two grouped factors? Basically, both factors contain, so here's a parenthesis recognizing it as a factor, and here's another one. So each factor in this case contains two terms. So each term needs to be distributed to each term in the other factor. So I'm going to distribute term by term and try and keep track. So I'm going to distribute term by term. And basically keep track of the factors, right? Or keep track of the terms. Keep track of maybe like terms as I do this. So I want to make sure I have some kind of method to keep track. So I just use arrows. The first term in the first factor, this 3a squared, I'm going to distribute that to the two terms in the other factor. So when I do that, I'm just going to write my answer underneath this first term here. 3a squared times a squared would be a 3a to the fourth. The next term, 3a squared times negative b, would be a negative 3a squared b. So now I'm going to switch colors, but I'm going to take the next term in the first factor, which is the negative 7b, and distribute it to both of those terms. So if you notice, negative 7b times a squared would be a negative 7a squared b, and that's the same term that we got from the other distribution. Negative 7b times negative b would be a positive 7b squared. So the four distributions created these four terms, and I kind of just organized them in a vertical format with like terms. So now I can just combine like terms, and here I get a 3a to the fourth. I get a negative 10a squared b, and then a positive 7b squared. So again, we can, as we distribute, we're keeping track of our terms, and then we can combine any like terms if we run into any. So again, the same thing with the next expression. We have a grouped factor here. It has two terms in it. Maybe we call it a binomial factor. And then the next grouped factor has three terms in it. And maybe we call this a trinomial factor, just to use the terminology for polynomials. So again, I'll take and distribute the first term, the 3a squared, to every one of the terms over here. I get 3a squared times 2a to the fourth would be a 6a to the sixth. 3a squared times a negative 1, basically a squared, would be a negative 3a to the fourth. And then 3a squared times negative a would be a negative 3a cubed. So now, distributing through the next term, the negative 1, let's distribute that. Again, I'm using green to keep track, but I get negative 1 times 2a to the fourth would be a negative 2a to the fourth. So I'm going to put that underneath my already a to the fourth term. Negative 1 times negative a squared. So that would be a positive a squared. I'm just going to move that out and not put it underneath the a cubed term. And then negative 1 times negative a is a positive a. So again, I'm just kind of using columns to organize the terms as I distribute. It just makes it easier to combine like terms when I'm done. So I only have these two like terms to put together. So my answer is going to be a 6a to the sixth. Negative 3 and negative 2 is negative 5a to the fourth. Just combining the terms. I have this negative 3a cubed. I have an a squared and then an a. So again, all those terms are different powers on the variables. So the idea is to just distribute term by term and keep track of like terms so that you can combine any at the end.